Okay, we're in Chapter 3, Exponential and Logarithmic Functions. Today starts Lesson 3.1, which is Exponential Functions. We are dividing it into two parts, so we are only going to be discussing evaluating, analyzing, and graphing exponential functions. Now, I'm going to go through some of this stuff very quickly, so pause when you need to, rewind when you need to. First off, it is an exponential function, and the difference between the exponential function and what we talked about earlier, which was our power function, is now we have the variable in our exponent instead of in the base. So looking at these two graphs, we have this graph that is increasing, going up the whole time, and this graph that is decreasing or going down the whole time. The important thing to remember about these, when the one is going up, that's when we have our b value being greater than 1. And if it is going down, then our b value is between 1 and 0, because b will never be negative. We can talk about that later. Okay, so let's fill in the information of what we know. Our domain from this graph is negative infinity to infinity. Our range is from 0 to infinity. Our y-intercept is 0, 1, because if you put 0 in here, anything to the 0 power equals 1. So we've plotted that point 0, 1. Our x-intercept, it never crosses the x-axis. It does not have an extrema, any extrema. And our asymptote is y equals 0. So as we go, which is what we're fixing to talk about with this end behavior, okay? So our end behavior says the limit as x approaches negative infinity, that's going to be my left arrow, of f of x equals 0, because that left arrow is getting closer and closer to 0. And the right arrow is the limit as x approaches positive infinity of f of x, and that of course equals infinity. Our continuity is everywhere, so we write negative infinity to infinity. Do not write yes, do not write continuous. Write, give me an interval of where there is continuity, or tell me where there's discontinuity and what kind you have. Okay? This one, where the values are continually going up, is an example of exponential growth. Okay? On the flip side, if it's going down, we have exponential decay. Our domain is still negative infinity to infinity. Our range is still 0 to infinity. Our y-intercept is still 0, 1, because anything to the 0 power equals 1. So I still have that same y-intercept. X-intercept, again, there is none. Extrema, none. Asymptote, y equals 0 still. And our end behavior, hopefully you can see that that changes as x approaches negative infinity of f of x. Okay, that's my left arrow. It's going up to infinity. And the right arrow, which is the limit as x approaches positive infinity of f of x equals 0. And it is continuous everywhere. So we give the interval negative infinity to infinity. Okay, so we are going to spend this part of the section graphing, and then we'll answer questions about the function to analyze it. And what I'm going to do to help make the video as short as possible and get through the hardest part, which is the actual graphing, and then I'm going to pause it and fill in the information. So you can pause it and then write down all your domain range and see how you do and check your work. Okay, so to start off with, I need to go back and talk about key points, because I think you know by now I'm really big on key points. And my key points for exponential growth are negative 1, 0, and 1, and b, 1, and 1 over b. Our exponential decay, okay, x values are still negative 1, 0, and 1. But this time, oh, that's not, that looks like a 6. Oh, goodness. Negative 1, 0, and 1. 1 over b, 1, and b. Okay, so the important thing that we're going to do every time we graph, okay, we're going to go, we're going to use our key points. This is the other thing that's really important is our asymptote and our key points. So on this side, I'm going to have to use a different one. Let's see, asymptote and key points. That's what I'm going to refer to every time I am graphing. So I'm trying to get those in my brain. And we know our key points and we know the shape, so we're going to be able to graph lots of functions. Okay, so when I look at this first one, I have 6 to the negative x. Now, that is the same thing as 1 over 6 to the x, which is the same thing as 1 over 6 to the x. Okay, and I kind of skipped over it, but I put it right here. This is the little tip that reminds you 1 over b to the x and b to the negative x are the same thing. So that's what I've done, just use the property of negative exponents. Okay, more importantly, what is b in this function? Okay, right here it tells me b is 1/6. So my key points over from that right side for exponential decay always have -1, 0, and 1. But b is 1/6. This is always 1. And this is the flip of that. So I'm going to go graph. And I like somebody was doing this and I kind of like it. So I'm going to go with it. Let's try that one. My asymptote is y equals 0. Okay. And then I'm going to plot my points. -1, 6, 0, 1, and 1, 1/6. And from there, I know the general shape, so I'm going to connect. And try not to cross that asymptote. Put arrows on both sides so we know that it goes both ways. All right, I'm going to pause the graph right now and I'm going to go answer all the questions about domain, range, intercepts, asymptotes, and behavior and where it's increasing or decreasing. So then you can pause it right now, answer the questions, or you can go ahead and copy the information. Okay, there is the information to analyze that graph. So hopefully you got it all correct. Now we're going to go up and graph g of x equals 5 to the x. Okay, again, you want to identify what your b is. In this case, b is equal to 5. So I have my values using my key points, -1, 0, 1, b, which is 5, 1, and 1 over b. And my asymptote is y equals 0. So I'm going to go down to my graph and I'm going to plot my asymptote, which was y equals 0. And then I'm going to go plot my points, which -1 was 1/5. At 0 it was 1. And at 1 it is 5. And then I know the general shape, so I'm going to try to approach that asymptotically and connect my dots. Again, pause. I'm going to analyze the graph and then you can start back to see how you did analyzing yourself and getting some practice. Okay, there's your information for analyzing the graph. Let's go graph the next one. We have h of x equals 1/4 to the x plus 1. So when I look at this graph, again, we got to identify your b. b is 1/4. This one is outside, so I know that that shifts, it affects the y, which is up or down. And I write up or down. It affects the y because it's outside and it does the same thing. And so plus means I'm going to go up 1 unit. So I'm actually going to add 1 to each of the y values. But first off, you want to label your key points or write down your key points. -1, 0, 1, 1/4, 1, and 4. And from here, because of my 1 on the outside, I'm going to add 1 to each y value. My x's stay the same, so I have 1 and a fourth, I have 2, and then I have 5. And here, my asymptote was y equals 0. Now it's going to be y equals 1 because I'm supposed to add 1 to every y value. So let's go plot that graph. Here is my asymptote is now y equals 1. And my points are -1, 5, 0, 2, and 1, 1 and a fourth. Again, knowing that you've got to approach that asymptote with these dots is really going to help you make sure that you graph things correctly. And I am not crossing that asymptote. Okay, again, pause. I'm going to analyze the graph, and then you can check your answers. Okay, moving right along, here are the answers to analyzing the graph. Pause if you need more time to check your answers. We are going to move on and do some more graphs. We don't have to analyze them as much. But this particular example, we're going to use the graph of 4 to the x to describe the transformation that results in each function, and then sketch the graph of the functions. Okay, so if I am using 4 to the x, I'm going to write those key points down. And that is -1, 0, 1, 4, 1, and 1/4. Those are the key points, and of course my asymptote is y equals 0. So let's go talk about what kind of changes we see. Okay, you have a -2. This is outside. It's not up there with the x. So this means that it affects the y value, and that means that's up or down, and we do the same thing that we see. So I know this is moving my graph down 2 units. So what I'm going to do, okay, remember that it affects the y value. So I'm going to keep my x values the same, but I'm going to subtract 2 from each y value. So 1/4 minus 2 is -1 and 3/4. 1 minus 2 is -1, and 4 minus 2 is 2. And again, my asymptote was y equals 0. Now it will be y equals -2. So I like to, again, first off graph the asymptote, because then I have some idea of which way my graph is going to go, and it'll really help you out when we get to logs later in the chapter. And then I plot my points. So I'm going to go -1, -1 and 3/4. That's pretty close to the number 2. Then I have 0, -1, and I have 1, 2. So I know that I have to approach my asymptote, so I'm going to start over there, and then I'm going to connect my dots to make it look like the exponential function. Okay? 2b. -4, m of x is -4x to the 2. Okay? You know that the negative flips my graph over the x-axis. Okay? So that's changing my y values, giving me the opposite of every y value. And then I have this 2, which is inside, because it's up here with the x. It's actually inside, and it's moving my graph to the left 2 units. Because when it's inside, it affects the x, it does the opposite. So I have my key points of 4 to the x, and this time I'm going to change each y value, and it's going to have an opposite sign. So instead of 1/4, I'm going to have -1/4. Instead of 1, I'm going to have -1, and instead of 4, I'm going to have -4. My x values, I'm going to subtract 2. -1 minus 2, 0 minus 2, and 1 minus 2. And from there, I'm going to go, let's talk about our asymptote. Y equals 0. Well, the opposite of 0 is 0. So hopefully you can see that that means our asymptote is not going to change. So put my asymptote, y equals 0. Okay, that was a really bad line. Good thing I have autocorrect. And I'm going to plot my points. -3, -1/4. -2, -1. -1, -4. Okay, so again, I'm going to approach the asymptote and connect my dots to make it look like the exponential function. It got flipped over our x-axis, and then it shifted over, because we were normally going to be here, but we shifted over to the left 2 units. Okay? And the last one we have on this example, we have 2 times 4 to the negative x. Okay, this 2, I'm sure y'all remember, is a vertical stretch. So if it's vertical, that means it's affecting the y, and I'm going to multiply times 2 every y value. And this negative, it flips it over the x-axis, and try to get that s in there, flips over the x-axis, and so I'm going to change each of my, I'm sorry, not x-axis, y-axis, flips it over the y-axis, and I'm going to change each of my x values to the opposites. Okay, so again, I'm working with my key points up here, and I'm going to say, all right, normally I would have negative 1, 0, 1, but every x has to have the opposite, so it's going to go 1, 0, negative 1. And I multiply each y value by 2. So 1/4 times 2 is 1/2. 1 times 2 is 2, and 4 times 2 is 8. So hopefully you can see that vertical stretch happening. My asymptote is y equals 0. If I multiply that by 2, I'm still at y equals 0. So we'll put in our asymptote y equals 0, and we're going to graph 1, 1/2, 0, 2, and negative 1, 8. Okay, so you can see that my graph is, I missed. Let's try that one more time. We won't belabor the point. All right. Um, and you're just attempting to approach it asymptotically and not go over it. So there we have some graphs of transformations. All right. The last thing that we need to talk about is something called the natural base. Okay. These are, it's actually a number that we use it as a base, and it's found in real world applications more often than the number 2 or the number 10. Okay, but more importantly, what does it represent? It is the value of this expression, the limit as x approaches infinity of 1 plus 1 over x raised to the x, which is what I have right here. So as x goes to infinity, so as I make my x values bigger and bigger and bigger, you can see that this number is getting closer and closer to our number e. It stands for Euler's number, and it is, if you want to carry it out, 2.7182815904523, on and on and on and on and on. Okay? It is an irrational number, just like pi. But it is used so much in math that we're actually going to graph it and do some transformations, and then we'll be done. So we have e to the x, okay? And as we just said, all right, it is a value. So let's go figure out what those key points are. I have negative 1, 0, and 1. If I put in 1, I'm going to have e. And then I'm going to have 1, and I'm going to have 1 over e. Those are my key points. Still have the same asymptote, y equals 0. So what happens if I switch? I have this negative sign, as we just talked about. It's going to flip it over the y-axis. Okay, it is involved with the x. The x is what is affected, and when I flip it over the y-axis, my x, I get the opposites. So I'm taking my key points over there. My y values are not changing. I have 1 over e, 1, and e, but I'm going to take the opposite of my x values. So we go and graph it. Graph my asymptote. Okay, negative 1e, negative 1e, which is 2.7, so I'm going to go close to 3, but not quite there. I still have 0, 1, and 1 over 2.718, about 1/3, and I'm going to graph, connect my dots, and show me that it approaches that asymptotically. Okay, look at the next one. What happens here? This is outside, so it affects my y, and I do the same thing. which means I'm going to shift down 5 units. I'm going to take my key points that I have right here, and I'm going to subtract 5 from each of them. So I have -1, 0, and 1. And then I have e minus 5, -4, and 1 over e minus 5. Now we write it like that, but we have to have some idea of how to graph it. So just put it in your calculator, and you'll find out that this is -4.6 about, and e minus 5 is about -2.28. So when I go and graph it, I'm going to use my decimal approximations. I'm going to put my asymptote, and at -1, I have -4.6. -1, -4.6. So that's, I was like, this didn't make sense. Because y'all aren't here keeping me awake and helping me stay on track. Okay? We shifted every y value down 5. So my asymptote is no longer 0, but down 5. And y equals -5. So my asymptote is down here. So from here, when I put in the point -1, -4.6, you can see that I'm close to that asymptote, but I'm not going to cross it. Okay, 0, -4, and -2.28, which is just over the border for 2. So I have my points. There's my asymptote. I'm going to approach it, and I missed, but y'all got the idea. Hard to draw on the airliner. Okay, last problem. And if you got it, feel free to go on, check the notes. You'll have the answers right there for you to look at. Okay, what does this 3 do? It's outside. It affects the y. It does the same thing, and we call that a vertical stretch of 3. So each y value that I have from my original key points, my y values are going to change. My x's are not. I'm going to have 3e, I'm going to have 3, and I'm going to have 3 over e. Again, put it in a calculator to get an estimate. 3 over e is about 1.10, and 3 times e is about 8.15. Okay? My asymptote y equals 0 times 3 is still 0. So I'm safe with my asymptote. Y equals 0. And my points, -1, 1.1, just a little bit over. Yeah. And 1, 2, 3, 0, 3, and then 1 is 8.15, which is going to be way up there. So again, approach that asymptote and connect your dots. And there you have it, graphing exponential functions.